Exponential growth, exponential decay, exponential growth. When it's graphed, it looks something like this. Like it'll swoop up at a pretty steep rate. Exponential decay swoops down into the right, but it's not a straight line. It's a curved line. So the way you're going to determine if it's growth or decay is you look at the number with the exponent. So in our first example, you'll see y equals 2 to the x power. If the number with the exponent is larger than 1, it would show exponential growth. If the number is between 0 and 1, like if it was 1/2 to the x power, that's between 0 and 1, that would show decay. So we'll get there. The first few are growth, and then we switch over to decay. And I know you guys are very passionate about rabbits. So a warren of rabbits, I didn't even know that was a word. A warren of rabbits starts with one male and one female. The number of rabbits then doubles each month. The function y equals 2 to the x models the number of rabbits in the warren. For the function y equals 2 to the x, make a table with integer values x from 2 to 5, then graph the function. So, do we need a table? No, not necessarily. But these are the x's they want us to use. They want us to use integers from 2 to 5. So 2, 3, 4, and 5. These are numbers we're going to be substituting in for x. So it was 2 to the x power, so this would be 2 to the second power, 2 to the third power, 2 to the fourth power, and 2 to the fifth power. Now with all these functions, when you actually solve it, it gives you the y coordinate. So here, we'll write the full coordinate. We already know the x is 2, and then 2 to the second power is 4, so our y is 4. Here, when x was 3, 2 to the third power is 8. Here, when x was 4, 2 to the fourth power is 16. And when x was 5, 2 to the fifth power is 32. You might also notice a pattern here. As you go down your y's here, 4 to 8 to 16 to 32, they're all being multiplied by 2. What? So we're going to have to graph these. Now, I left the graph intentionally blank. To me, it seems easier to actually graph these ones with blank graphs. So our highest number is 32. So we just have to make sure that we include at least 32. So you know what? Let's bump it up to 40. I like to choose numbers that are easy to cut in half, because then we can go about halfway up and make it 20. And then it's pretty easy. You're going halfway up to 20. So that would be like 10. We can mark a 10 pretty easy. And then so 10, 20, here would be 30. We don't need to label the other stuff, but we can make this like line for every 5. 5, 10, 15, 20, 25, 30, 35, 40. Cool. And then down here we'll have the number of, days or weeks. So we'll have, we skipped 1 and 0. It said to do it 2 through 5. But if it was 1, what's 2 to the first power? It would be 2, right? So there would be a dot at 1, 2, which would be about here. At day 2, it was up to 4. Day 3, it went up to 8. Day 4 was at 16, is about there. And day 5 was up to 32. Now day 0, they don't really include here, but 2 to the 0 powers is 1. So that kind of doesn't really work for what we're dealing with here. But this will give you a nice curved line up. I have one that I'd like you to try now. And this one is 3 to the x. So pause it here. I'm going to write the word for it real quick, and then check if you end up with the same thing. So 80 is a nice even number. So if we made this 80, and then we'll just make 81 a little bit above it. So half of that is 40. We can split those with 60 and 20. We can throw in 10s in between those. We have 1, 2, 3, 4. All right. 1 is at 3. That's about there-ish. 2 is at 9. 3 is at 27. That's about there. And then 4 is at 81. So it gets pretty steep there. We'll pretend like I actually hit that dot. So hopefully you did well. Let's try another one. Now again, you'll see the 0.25, but that's not the number with the exponent. The 4 has the exponent, so it's still going to show exponential growth. So it wants us to use 0 to 4. 0, 1, 2, 3, 4. So we have to do 0.25 times 4 to the 0, 0.25 times 4 to the first, 0.25 times 4 squared, 0.25 times 4 to the third, and 0.25 times 4 to the fourth power. All right, so order of operations says that you do your exponents first, and then you do multiplication. So 4 to the 0 is just 1, and 1 times 0.25 is 0.25. So our coordinate will be 0 and 0.25. When we put in 1 for x, 4 to the first is 4, and 0.25 times 4, 0.25 is like 1/4. So a fourth of 4 would be 1. When we put in 2, 4 squared is 16, a fourth of 16 is 4. Here we go with 3, 4 to the third is 64, a fourth of 64 would be 16. And when we put in 4, I think it's 256, and then a fourth of 256 would be 64. So here are our coordinates. We have to make sure we include at least 64. So we could toss 60 right there and just go a little bit above it. We would have 30. We can go by tens. Let's try to make this even-ish. 10, 20, 30. We're just trying our best to keep it in scale. We're just going for a general graph here. We're going 0 to 4. 1, 2, 3, 4. There's the graph. So 0 and 0.25, that's way down there. We're at 1, 1, that's still way down there. 2, 4, we're about almost halfway to 10. 3, 16 will be here-ish. And then 4, 64. So a pretty steep swoop. Let's pretend like our line hit there. All right, now I got one for you to try. They want to do 0 through 5. So try it out and then check back in. Make sure to include at least 16. Half of 16 is 8. Let's split that by 4s. 12, 2, 4, 6, 8, 10, 12, 14, 16. 1, 2, 3, 4, 5. All right. 0, 0.5. There-ish. Got 1, 1. 2, 2. 3 is at 4. 4 is at 8. 5 is at 16. Cool. Now we're going to go into exponential decay. So 60 times 1/2 to the x power. Remember, if it's between 0 and 1 with the exponent, that would show decay. So we want to use 0 through 5 here. I'm going to scooch over for a minute. X 0, 1, 2, 3, 4. of 60. No, it's probably going to be easier if you're cracking off a bunch of these in your calculator. 1/2 as a decimal is 0.5. All right, so 0.5 times 0 is 1. 1 times 60 is 60. So we're at 0, 60. 0.5 to the first power is 0.5 or 1/2. Half of 60 is 30. Now you'll also be able to use patterns with these. Look at what's going on. You go from 60 to 30. You're cutting it in half, right? You're cutting it in half. So half of 30 is 15. Half of 15 is 7.5. I don't know what half of 7.5 is. 3 point something. 3.5. Oh, I did half of 7. 3.25. I guess. What is going on? Yeah, my brain is done. This is the end of the day. 3.75. And then if you divide that by 2, or take half of that, it's 1.875. So we need to make sure we include 60. So if we make this 60, this 30, we go by 10s now. 10, 20, 40, 50. And then halfway between would just be the 5s. 1, 2, 3, 4, 5. Alright, 0, 60. 1, 30. 2 was 15. Then it was 7.5. And then it was like 3.75. And then it was like 1 point something. So this will swoop down into the right. Awesome. Now I have one more for you to try, and then we're done. So here you have 1/3. So really you'll be dividing those numbers by 3. So try it out. Oh dear. Point 3. And 5. So it's all 1/4. We're not going to be able to see the difference on the graph anyway. So if we made this 100, and this was 50, we throw in a 75 and a 25. 1, 2, 3, 4, 5. 0.90 about there. 130 is about there. Quick drop off. 10. Nice. All right. There we go. Exponential growth and decay. Hope you are singing along.